A circuit breaker is an electrical switch intended to protect a circuit from harm due to overcurrent or overload or short circuit. Its principal function is to break the flow of current after protective relays have sensed a fault. In these photos, you can see different types of circuit breakers that we will discuss within the video. How does a circuit breaker work? The circuit breaker consists mostly of fixed and moving contacts. In the normal ON condition of the circuit breaker, these two contacts are interconnected physically by the mechanical pressure applied to the moving contacts. The potential energy is stored in the circuit breaker switching mechanism and will be released when the switching signal is given to the breaker. The potential energy can be stored in the circuit breaker in a variety of methods, such as by a deformable metal spring, by compressed air, or by hydraulic pressure. However, regardless of the source of the potential energy, it must be released during operation. The release of potential energy results in rapid sliding of the moving contact. All circuit breakers have operating trip coil and closing coil, which are energized by a switching pulse and displace the plunger inside. The plunger of this operating coil is usually connected to the circuit breaker operating mechanism, which releases the mechanically stored potential energy in the operating mechanism in the form of kinetic energy that sets the moving contact in motion. As these moving contacts are mechanically connected to the operating mechanism by a gear lever arrangement. After one operating cycle of the circuit breaker, all of the stored energy is released, and thus the potential energy is again stored in the circuit breaker operating mechanism by using a spring charging motor, air compressor, or other means. Let's introduce you different types of circuit breakers. AC circuit breaker. An AC circuit breaker is a safety switch that is usually built into your home's electrical system. It looks like a switch that helps cut off the flow of electricity to any component or device that consumes a lot of power. High voltage circuit breaker. Major power transmission networks are typically managed by high voltage circuit breakers. This type of circuit breaker is used when the voltage rating is greater than 600 volts. They are driven by solenoid coils, with current-sensing protective relays controlled by current transformers. High-voltage AC circuit breakers are available with ratings up to 765 kV and 1200 kV. These circuit breakers can be arranged to allow tripping of a single pole of a three-phase line, rather than tripping all three poles. Circuit breakers with all three poles are used for certain fault ratings and improve system stability and availability. Low-voltage circuit breaker. A low-voltage circuit breaker is designed for circuits rated 600 volts or less. The most common low-voltage circuit breaker is a molded case circuit breaker. Low-voltage circuit breakers are commonly used in residential, commercial, and industrial applications. Low-voltage molded case circuit breakers can be equipped with an electric motor that opens and closes them remotely. These types are also used for DC applications, such as DC subway lines. Miniature circuit breaker. These types of circuit breakers are used as a replacement for fuses and are used to protect the circuit from overcurrent. Circuit breakers are automatic switches that open when the current flowing through them exceeds the adjusted value. They protect low-voltage 240 or 415 V AC circuits with a wide range of currents below 125 V. This circuit breaker does not need to be replaced each time. If a trip occurs, it can be used again. They are mainly used in households, light industry, and commerce. This type of circuit breaker is more liable to current than a fuse. By its use, the faulty area of the electric circuit can be easily identified. It can provide a better interface with the help of a knob as compared to a fuse. They are more expensive than fuses. The cost of an MCCB distribution board is also costlier. Installment and repair are expensive as compared to fuse. Single-pole circuit breaker. In control panels, single-pole breakers look like slim switches. Single-pole circuit breakers are used for many applications, including general lighting power outlets, vacuum cleaners, fans, power tools, curling irons, outdoor lighting, radios, computers, DVD players, and air compressors. Single-pole circuit breakers are usually wired with a hot wire and a neutral. If an overload occurs in a single-pole circuit, only that particular breaker will trip. Double-pole circuit breaker. In control panels, double-pole breakers look like double throw switches. They can also be used to power appliances with low-voltage circuits, central air conditioners, clothes dryers, water heaters, baseboard heaters, and even hot tubs. Double-pole breakers consist of two hot wires connected to a neutral wire. With this design, a short circuit in the wires of any of the two poles causes both to trip. They are typically used for a single 240V circuit, but can also be used for two separate 120V circuits. Molded case circuit breaker. The molded case circuit breaker is a circuit breaker with a high current rating of up to 2500 amps. They are generally used where the current exceeds the limits of the MCCB or miniature circuit breaker. This circuit breaker uses a thermal magnetic trip mechanism, with the thermal mechanism used for overload and the magnetic for short circuit. It can quickly dissipate a current of about 200 amps. They protect devices such as generators, electrical supply lines, capacitor banks, motors, etc. MCCB is compact and saves a lot of space in panel design. They can protect electrical equipment from faulty conditions. It could easily be reset or restarted immediately if a fault is found. The cost of MCCB is more as compared to the MCB-type circuit breaker. This type of circuit breaker requires regular maintenance. If a lot of MCCB is used inside the panel board, it must be cooled. DC circuit breaker. A DC circuit breaker protects electrical devices that are operated with DC current. It has additional measures to extinguish arcs. These technologies are relatively new to most homeowners, as most appliances in homes are AC powered. These circuit breakers use 24-volt DC to 48-volt DC. Although both AC and DC breakers look the same, they operate very differently internally. When an overload occurs, the internal contacts of AC and DC circuit breakers are separated to protect the circuit. HVDC circuit breaker. The HVDC circuit breaker is a switching device that interrupts the normal flow of current in the circuit. These circuit breakers provide a very efficient way of transferring power over long distances. Nowadays, they are used in various green power generation applications. When the HVDC circuit breaker opens, the breaker in the LC circuit closes. Due to the charged capacitor, the discharge current starts to flow in the opposite direction to the load current of the circuit breaker. As a result, the arc current begins to generate many natural zeros. These are suitable for networked DC networks and multiple DC connections. They provide both high efficiency and fast switching. It can allow the system to be much smaller than other traditional equipment. HVDC requires conversion, switching, control, availability, and maintenance. Bulk oil circuit breaker. This type of circuit breaker uses oil arc extinguishing agents and insulating media between the live contacts and the grounded parts of the breaker. The amount of oil required for this circuit breaker depends on the system voltage. An oil-filled circuit breaker requires a large tank, which increases the cost and weight of the circuit breaker. This type requires less space because the oil quality is low. Here, a small amount of contact separation is sufficient to clear the breaker. Minimum oil circuit breaker. The minimum circuit breaker uses oil as the interrupting media. In this type of circuit breaker, the interrupter unit is held in an isolation chamber at the live potential. Since less oil is required, it is referred to as a minimum oil circuit breaker. Air circuit breaker. This circuit breaker operates by using air, as the name implies. Air circuit breakers protect low-voltage circuits, mainly activating and disconnecting the high currents. In some countries, circuit breakers are replaced by oil circuit breakers because they work efficiently. Therefore, the importance of ACB is still a better option for the use of miniature circuit breakers up to 15 kV. ACBs are used as protection devices for industrial equipment and electrical machines such as capacitors, generators, transformers, and so on. Since the circuit breaker uses air as the medium, it is cheap and chemically stable. The air blast circuit breaker has the capability to operate at high speed. The air circuit breaker eliminates the fire hazard, unlike the oil circuit breaker. In case of arc interruption, it produces a high noise when air is released into the open environment. The problem of cutting off current exists in the air blast circuit breaker. There is trouble with restriking voltage. Air blast circuit breaker. The air blast circuit breaker uses a high-pressure air stream as the arc extinguishing medium. This type of circuit breaker is used in open high-voltage applications with a voltage range of 245 kV and 400 kV to 765 kV, especially where fast operation of the breaker is required. Compared to SF6 and vacuum circuit breakers, blast air circuit breakers are rarely used today. Compressed air circuit breakers use compressed air or gas as the switching or interrupting medium. Compressed air circuit breakers offer many advantages, such as fast operation, automatic closing, low maintenance, and more. SF6 circuit breaker. The SF6 circuit breaker is a circuit breaker that uses pressurized sulfur hexafluoride gas to extinguish the arc. It is a strong dielectric gas with better insulating and arc extinguishing properties than air or oil. It is commonly used for arc extinguishing in high-voltage switches up to 800 kV in power plants and power grids. When an arc is fired between contacts, it absorbs the free electrons and converts them into negative ions, which are heavier than electrons. SF6 gas has low mobility, which increases the dielectric strength of the medium, as the movement of the charges is responsible for the current flow. The benefit of SF6 gas is that it is inflammable and chemically stable. It is decomposition products, so there is no risk of fire or explosion. Due to the high dielectric strength of SF6, the electrical clearance is greatly reduced. These are expensive due to the high cost of the SF6. Internal parts in a clean and dry environment require cleaning during periodic maintenance. For transportation of a special facility, it requires maintenance of gas quality. Vacuum circuit breaker. This type of circuit breaker is mostly used in high-voltage installations and performs a similar function to the breakers in a home power panel. The function of this device is to interrupt the power to an electric outlet in the event of a short circuit or electrical fault to allow manual disconnection of the circuit so that it can be repaired. An unique feature of vacuum circuit breakers is that they have a free space. The performance of a vacuum circuit breaker depends mainly on the material used for the current-carrying contacts, such as copper or chrome. It has a longer service life than other types of circuit breakers. They are compact in size and pose no potential for a fire hazard. The vacuum has high dielectric strength and does not produce gas after the operation. The drawback of VCB is that it is unviable at voltages above 38 kV. Generating a vacuum requires high technology. At high voltage, the circuit breaker becomes costly. If you liked the video, please don't forget to subscribe us and like the video. Thank you.